When Germaine was 13, the French Revolution began, and she was forced to stay inside because of the danger throughout the city. To fill her time, she turned to her father's library. Here she found and read many books that interested her, especially mathematics by Archimedes. Germaine knew that if geometry could hold such fascination for Archimedes, it was a subject worth studying. So she quickly read every book on mathematics in her father's library. Her parents did not approve of her sudden interest with mathematics because it was thought inappropriate for a woman to study. When night came, her parents tried many things to keep her from studying. But after they left, she would take out candles, wrap herself in quilts, and do mathematics. After some time, her mother secretly began to support her study of mathematics. In 1794, when Germaine was 18, a mathematical school called École Polytechnique opened. As a woman, Germaine was not allowed to attend. Wanting to learn all she could on the subject of mathematics, she required lecture notes from male students. Germaine obtained the lecture notes and began sending her work and notes to Joseph Louis Lagrange, who was a faculty member at the school. She used the name of a former student, Monsieur Leblanc, in order to submit her work for consideration since women were not allowed to attend the school. When the professor saw her intelligence of Monsieur Leblanc, he asked to meet him, and this caused Germaine's secret to be discovered. Fortunately, Lagrange did not mind that she was a woman, and became her mentor. Later, Germaine became interested in the number theory. In 1798, when Adrien Marie Legendre published Histoire sur la théorie des nombres. After studying the work, she began corresponding with him on the number theory, and later elasticity. Germaine's interest in number theory increased when she read Carl Friedrich Gauss's interesting book Disquantance Arithmetis. After 3 years of working through the exercises and trying her own proofs for some of the theories, she wrote to the author Carl Friedrich Gauss, again using the fake name Monsieur Leblanc. The letter presented some of Germaine's work on Fermat's last theory. Gauss was mostly uninterested and didn't respond to any of her correspondence. When Germaine's correspondence with Gauss ended, she took interest in the contest, sponsored by the Paris Academy of Sciences. The object of the competition was to give the mathematical theorem of the vibration of an elastic surface and to compare the theory of experimental evidence. In 1809, she began her work on the contest. After 7 years, she submitted her final attempt, which helped her study the number theory. On January 8, 1816, she became the first woman to win a prize from the Paris Academy of Science. Germaine's best work was in the number theory, and her most significant contribution to the number theory dealt with Fermat's last theorem. In 1815, after the elasticity contest, the Academy offered a prize for a proof of Fermat's last theorem. It renewed Germaine's interest in the number theory, and she wrote to Gauss again after 10 years of no correspondence. Fermat's last theory is commonly divided into two cases. Case 1 involves all p that do not provide any of x, y, or z. Case 2 includes all of p that divide at least one of x, y, or z. Germaine proposed the following, commonly called Sophie Germaine's theorem.